Hi, my name is Patrick. I'm a Python engineer here at SkyEngine AI. Today, I will be showing you how to adjust camera parameters inside the vehicle cabin in the DMS blueprint. For each example, we will be starting from the same place, the dashboard of a blueprint in the synthetic data cloud. I'm in the dashboard section of the DMS blueprint. From here, I go to the scene params file, the code editor section. To change the modality, you need to type in your desired modality in the field here. I am changing modality from visible light to near infrared. After saving the settings, we need to go back to the dashboard and create a new rendering task to generate the dataset with new settings. The rendering is done. As you can see here, these two images are identical except the modality. The left image is rendered in RGB and the right one is rendered in near infrared. Near infrared is very similar to black and white imagery, however, there are differences. For example, color patterns disappear in near infrared, which is caused by the physical differences in the interactions of light or electromagnetic radiation with matter. This physics-based approach we use at SkyEngine AI ensures that the representation of scene features is adequate to the modality used in rendering. We will start the change of camera type from the same place as previously, that is, from the dashboard of the DMS blueprint. In the dashboard, we select the scene params file and go to the code editor section, where we find the camera type parameter. In this presentation, I want to change the camera type from pinhole to fisheye, so I type fisheye here. Next, it is necessary to save the changes, so I click here, and then I go back to the dashboard to start a new rendering task. I choose to start a new task and click Start. Now we wait for the rendering to finish.
A few hours later.
The rendering is done. It took 6 hours and we created 3000 images. I will show you now the difference in the scene caused only by this change of the camera type. On the left hand side, you can see a scene depicted through the pinhole camera, similar to ones you have in your smartphone, and on the right hand side, the same scene as seen through the fisheye lens. The latter displays characteristic object distortions and image quality degradations caused by the optical properties of the lens. The former naturalistically represents the scene, as if the image was obtained with a camera from a smartphone. Okay, the last feature of the synthetic data cloud I want to show you today is changing and randomization of camera position. Again, I will be using the DMS blueprint for this, and again, we will be starting from the blueprint dashboard. We go to the scene params file and find camera positions parameters located inside the common params section, positions drawing distributions. Here we can see that there are 5 available camera positions, and at the moment each of them is assigned a value. This value determines the percentage of the dataset that will contain this setting. They are weights, so if each value is 0.2, 20% of the dataset will contain images with a camera placed in that particular location. For our purposes, I want to change the setting so that the dataset contains 100% images seen from one location. The remaining parameters have to be manually reset to 0. Again, we save the new settings and return to the blueprint dashboard to start a new rendering task. So, here we have two datasets where all settings are exactly the same except the camera placement and randomization. In this case, you can see that the camera placement changes from image to image, while in this dataset, the camera placement is constant. By using this parameter, you can easily manipulate the statistical distribution of camera placement and fine-tune the dataset characteristic according to your machine learning needs. That's all for today. I hope I piqued your interest with this small presentation of the possibilities our platform provides. If you would like to learn more or book a demo, go to skyengine.ai. We will be happy to show you around our platform. Till next time.